quite a long topic. That's why. So shall we start? Can you see the hydraulic power supply screen?
Yes, sir. Yes, sir.
Yes, sir. We can see, sir. We can see.
Okay. In this, we will cover systems, filter units, starter pumps, engine-driven pumps, valve block, and electrical-driven pumps. So on the first day, we identified that we have got two engine tube oil pump. And they pump the oil through the cooler and the filter goes to the engine. And approximately 15% oil is sucked through, which will pass through the 6 micron filter. And of course, there is a bypass filter of 25 micron. So this oil, which is coming from the manual labor system, pumped through. Now, once it's passed through the 6 micron filter, that must have a standard called ISO 4406 3, that's a standard, and National Aerospace Code 708, which is a US standard. So one of this code must be applicable for this. So when you take your oil for sampling and analysis, it should be conforming to this standard. So which means the particle size will be very, very low. So here we got around 2.5 bar pressure. So this engine is having 4 pumps, 3 pump controlled by ACUs, and this will be controlled by ECU. So we have got the inlet sensors here, 1204. You can see yesterday I mentioned to you 12 stands for hydraulic system. So these are variable delivery pump. This is fixed delivery. Oil goes on the top. There are accumulators in the system as well. There are non-return valves so that oil will not come back and line will be filled with oil all the time. And there are 2 sensors on the common line, which is called 1201. 01, 2. So they are the outlet sensors, but they are all in the common line. This is for the inlet side of the pump. So in case there is enough pressure here, the engine should immediately shut down or something like that should happen. So we'll protect our pump. This is a double wall pipe. So if you are on a 200 bar system, I told you yesterday there will be a double wall pipe. So sometimes there may be some leak from the inner wall to the outer wall is possible due to pouring or sealing failure. If that happens, there will be a little bit of a leak which is coming here all the while, passing through this valve and going to the sump tank. There is no problem. And of course, the bigger engine, we always maintain certain amount of pressure to take care of here by actual vibration of the pipes plus the damage in the vibration of the vibration effect, and also to lubricate the seal ring and the voltage. So 5 to 6 bar pressure is okay, don't worry. So that oil will keep coming in, but we must understand there is another line here, another line here, another line here, which means they are all coming from different units and coming to the common line. Okay? The drain is only one line, all together connected to the one line. And if you see this is a normally open valve, which means all the time oil can leak. Okay. So now there is a little mechanism here. Here there's a PT 1234 or 32, I think. 33. Yeah. This PT is pressure transmitter, of course. So all the time the pressure is being monitored by this pressure transmitter. And here there is a activation system, which is this valve can be changed over or activated when the pressure reaches more than the spring force. The spring force is set for 50 bar. So which means when here the pressure reaches 50 bar. How the pressure can reach 50 bar from the 5 bar what I told you? How the pressure can increase here? Question to be answered.
So can you repeat the question, sir?
Why the pressure is going to 50 bar here? I say at 50 bar this valve will change over. Why so? Why the pressure can build up there? Can you see a little thing here? This is like a cross kind of a thing. What is that?
Orifice.
Orifice, sir.
Very good. So the orifice, when it get more pressure, more flow, it cannot take care of that excess amount of water. So the pressure will build up. Right? Same like the air cooler. Air cooler leak will give an alarm if the orifice is filled with a lot of water. Similarly, this will be operating when the leak is too much. So when the leak goes too high, let's say 50 bar equivalent, this valve will change over. Then can you see this line here? This line will come here, which is a plugged point, which means no more leak is possible to go to the sump tank. Okay. If this happens, you get an alarm at 50. But engine will continue running. There will be no slowdown. There will be no shutdown. So you have to come down, stop engine, and find out where the leak and fix it. Okay, but this is only for 200 bar system, not for 200 bar system. And of course, here we got a relief valve, what we saw yesterday, two for the pumps and 2 for the system. So that's the symbol diagram for a standard design. And if the ship owner wants to have a separate system for hydraulics, which means he doesn't want the sump oil to mix with the hydraulic oil, then he can keep a separate tank with a system oil, pump, cooler, filter, everything, and this oil will go back to that tank, not to the engine sump tank. So this option is available. If they want, they can always buy this. So these are the 3 different kinds of HPS system available in the market. One is a chain drive. If the bore size is more than 50, then you've got a chain. The bore size is less than 50, then you've got a gear. And between 6 and 7 and more cylinders, then the drive will be at the center. So these two, the drive is on the opposite side of the engine. Okay. More than 90 bore, etc., then you'll have more than 6 cylinder. Then it is better to keep at the center to reduce the costing of piping. Filter unit, that's the ball and fish filter. And there is one more supplier is there now. I'll explain you about the filter unit in a minute. And inside this cabinet, you've got all the pumps. All the engine-driven pumps are here. And you can see 2 pumps here on the top, electrical driven pump. They are also in an enclosure. So in case there is a leak, it will go inside and then of course it can give you an alarm. Can you see a casing here? This casing is nothing but the pipelines are enclosed here. And this goes to your HC. So if you look at here, there is already an enclosure outside which will protect in case there is a leak from the pipe flanges, connections, etc. And that is why for a 300 bar system, you don't need a double wall pipe. The double wall pipe is to protect in case there is a leak from the pipe. It should contain the similar way. If there is a leak from the pipe, this casing will do the containment. So there is no need of a double wall pipe for 300 bar system. And it may be a good idea once in a while open this and check inside there is any leak physically by using the flashlight. So that's your ball and fish filter version 6.64. That's the back flush filter. Inside this kind of an element will be there, and that's a 25 micron filter. I told you on the first day the compact engine, the circle has been cut like this. So then you can have more space. And you can keep a second cylinder close by. So initially we had 10 micron filter, then 6 micron filter. So now the 6 micron filter, how do you find out which one is 6, which is 10, if you have both of them on the ship? Your eyes cannot distinguish it. So the only thing that you can do is see the ID number. This is the month and the year production. That's ID number 446. This 446 actually is the ID of the number of filter, and they are now cindered filter material. Initially we had wire mesh, and of course in case there's a failure, the wire mesh will find a place in the FIBA valve and other parts. So it will cost very, very expensive damage to them. So therefore, it is better to have a cindered